name is Muhammad Izzatullah bin Mak Yusuf from BMKA Section 11.
My name is Muhammad Daniel Hakimi from BMKA S11.
My name is Rizal Akmal from BMKA Section 11.
Firstly, we need to lift up the car using a jack. Then, place the jack stand under the car to remove the wheel easily. Make sure there is nobody under the car during jacking up the car. Then we need to remove the wheel nuts using an air gun. For the nut, we need to use the 21mm to remove the nuts. Place the tire under the car for the safety. Place the tray under the disc brake and disconnect the hydraulic cable. Flush all the brake fluid out from the caliper. Remove the lock pin, but for our system, another lock pin is stuck because the bolt is loose. Take out the caliper from the rotor. This is the loose lock pin in the caliper. The next step is to remove the nuts at the caliper bracket. Remove the disc brake. Now, this is a part that we check the brake disc system. Make sure all the part is in a good condition. From here, we need to remove the brake pad from the caliper. For the rub test, we need to chalk the disc brake surface. To get the result, we need to rub the rotor with the brake pad slowly, steadily and unevenly. There are uneven chalk on the brake pad indicates that the rotor or brake pad is uneven. Then remove the piston caliper using air blow gun. Be careful to not place your hand under the caliper piston. For the inspection, this is our piston in the caliper. There is many rust on the surface. For the bolt ring and piston bolt is already in a good condition. The piston bore is also in a rusty condition, so we need to clean it up.
Next step is remove the piston seal from the caliper bore using the screwdriver carefully. Now we can see that the piston seal is a little bit dirty, so that we should clean it up. For cleaning part, we should remove the rust at the piston using sandpaper. Now is to check the lock pin straightness. We just rolling the lock pin in a plate surface. Before doing round out measurement, we should measure the thickness of the rotor with vernier caliper 6 times. Now, install the disc and screw the wheel nut for run out measurement. Using a micrometer, measure the disc at 6 different places around. The diameter of the rotor is about 10 mm from the outer ring. This is how we do the run out measurement test, and from the test we get the result is negative because of the rotation is anti-clockwise. From the result we can consider that the rotor need to be replacement. Next is using blowgun after wash and clean the caliper, and put the rubber grease at the piston seal. Then set up the seal at bore caliper. Next, put the rubber at the ball caliper and install the piston carefully. Install the piston boot. After that, install the boot ring using screwdriver. Make sure it can clip the piston boot tightly.
Install back the caliper mounting. Set up the brake pad at the caliper bracket. Tighten the nut of the caliper bracket. Install the pin boot for the bottom and top. After that, install the caliper. Next, put the pin lock. And tighten the pin lock using the gun. Connect the hydraulic cable. Make sure the washer cooper install. Okay, put the wheel and screw the wheel nut. Lift up the car using jack and remove the jack stand.
Good evening, sir. My name is Puarsan from BMKA S1/1. Today I would like to present about lab sheet 4, disc brake inspection, removal and refitting. Theory. Figure 4, drum brake part. Table 1, disc brake part name. First guide pin, second guide pin, third pin bushing, fourth mounting bracket, fifth pin boot, boot ring, piston boot, piston seal, caliper, outboard brake pad, inboard brake pad, shim, pad clip. Table 2, condition of disc brake parts. Number 1, wear indicator in a good condition, shape and be clear. Number 2, part name disc brake surface. Condition not in smooth surface because the result of run of measurement is negative value and need to be replaced. Number 3, outboard brake shoe pad. Condition lightly used based on the thickness that not less than 4 mm. Thickness 14.30 mm. Number 4, inboard brake pad, shoe pad. Condition lightly used based on the thickness that not less than 4 mm. Thickness 14.93 mm. Number 5, piston. There are rust around the piston. Number 6, cylinder bore. Condition a little bit dirty surrounding the wall and should put the rubber grease. Table 3, inspection of disc brake condition. Number 1, round out of measurement. Condition according the reading of indicator plunger, the value is negative since it moves anti-clockwise. Number 2, disc thickness measurement. First reading 23.91 mm, second 24.26 mm, third 24.20 mm, fourth 23.93 mm, fifth 24.05 mm, sixth 23.75 mm. Number 3, rub test. Condition they are uneven choke on the brake pad indicates that the rotor of brake pad is uneven. Number 4, guide pin or lock pin straightness. Condition the top lock pin is good condition based on perfect circle during rolling test on the flat surface, but another lock pin is loose and stuck in the caliper. That's all from me. I pass to Devaruban.
Thank you, Puarsan. My name is Devaruban Annalakivasu from BMKA Section 1/1. Let's move on to discussion. For discussion, the student should answer all the questions and follows. Based on your finding, what is the condition of the brake pad? Should it be replaced with a new pad? Based on our working, we can find that the brake pad is in the excellent condition, since the thickness of brake pad is only about 14.30 mm and 14.93 mm, so that we can consider that the brake pad does not need to be replaced because the thickness is not less than 4 mm, which is recommended. Second question, list two causes of rotor thickness variation. Which is the correct procedure of thickness variation? Two primary causes of rotor thickness variation are uneven wear occurs when there is uneven contact between brake pads and rotor, leading to inconsistent rotor wear over time. Moisture and road salt exposure can cause rust formation on the rotor surface, resulting in the high spot and thickness variation. Correct repair procedure for thickness variation, which is use a micrometer to measure rotor thickness at various points around the rotor to detect any variation of thickness. Replace worn or uneven brake pads to protect uneven wear on a new or resurfaced rotor. Third question. What do you understand about run-out measurement data? Detects rotor alignment issues, prevent vibration, uneven braking, and premature pad and rotor wear, and ensuring smooth contact for effective braking. What is your finding for your guide pin lock pin straightness check? What can happen to your disc brake system if the guide pin lock pin is not straight? Based on our result, on checking the straightness of the lock pin is straight, the caliper sliding shows for smooth. Allow contacting between brake pads and rotor, ensuring optimal braking performance. Consequences when lock pin is not straight. There are two, which are uneven brake pad wear occur when the caliper does not slide properly, causing one of the slide to wear faster than the other, reducing brake system efficiency and necessitating frequent pad replacement. Another one is misaligned guide pins can cause uneven distribution of braking pressure across the rotor, resulting in reduced braking power and response. Finally, let's move on to conclusion. In conclusion, the brake pads are in good condition with thickness of 14.30 mm and 14.93 mm is above the recommended level, which is 4 mm. Rotor thickness variation is likely to uneven wear and rust buildup, affecting braking efficiency. Proper repair involves measuring rotor thickness and replacing worn or uneven pads. Run-out measurement indicate potential rotor alignment issues, which may require replacement or realignment. The guide pin lock is in good condition, but a loosened pin could affect caliper movement, which can cause uneven pad wear and reduce braking power. Thank you.